The wave interference simulation is an interactive educational tool designed to help students explore and understand the principles of wave interference and diffraction. By providing a hands-on approach to investigating how waves interact and create interference patterns, the simulation offers a comprehensive learning experience that covers fundamental concepts in physics. The simulation allows students to generate waves using various sources, adjust the frequency and amplitude, and observe the resulting wave patterns. Additionally, students can explore how a pair of wave sources create an interference pattern, experiment with diffraction through different apertures, and adjust various parameters to observe their effects on the wave patterns. The wave interference simulation allows students to generate waves using a dripping faucet, speaker, or laser. Each source produces waves with unique characteristics, enabling students to explore different types of wave phenomena. For example, a dripping faucet can simulate water waves, a speaker can simulate sound waves, and a laser can simulate light waves. This versatility helps students understand the universal principles of wave behavior across different media. Students can adjust the frequency and amplitude of the waves to observe how these parameters affect the wave patterns. By increasing or decreasing the frequency, students can see how the wavelength changes. Similarly, adjusting the amplitude allows students to observe how the height of the waves affects their behavior. This interactive feature helps students gain a deeper understanding of the fundamental properties of waves. The simulation enables students to explore how a pair of wave sources create an interference pattern. When two waves overlap, they can interfere constructively or destructively. Constructive interference occurs when the waves are in phase, resulting in a higher amplitude. Destructive interference occurs when the waves are out of phase, resulting in a lower amplitude or cancellation. By observing these interference patterns, students can gain insights into the behavior of waves and the principles of superposition. Students can identify points of constructive and destructive interference by eye and by using detectors provided in the simulation. Detectors can be placed at various points in the wave field to measure the amplitude and phase of the waves. This feature helps students understand the spatial distribution of interference patterns and the conditions that lead to constructive and destructive interference. The simulation allows students to put up a barrier and observe how waves move through one or two slits, discovering the resulting interference pattern. By placing a barrier with one or two slits in the path of the waves, students can observe how the waves diffract and interfere as they pass through the slits. This experiment helps students understand the principles of diffraction and the formation of interference patterns. Students can determine how to change the interference pattern by adjusting the slit width and separation. By varying these parameters, students can observe how the spacing and intensity of the interference fringes change. This interactive feature helps students understand the relationship between slit dimensions and the resulting interference pattern. The wave interference simulation enables students to experiment with diffraction through elliptical, rectangular, or irregular apertures. By placing these apertures in the path of the waves, students can observe how the shape of the aperture affects the diffraction pattern. This experiment helps students understand the principles of diffraction and the role of aperture shape in determining the wave pattern. Students can adjust the dimensions of the apertures and the wavelength of the waves to discover the effect on the diffraction pattern. By varying these parameters, students can observe how the size and shape of the aperture, as well as the wavelength of the waves, influence the diffraction pattern. This interactive feature helps students gain a deeper understanding of the factors that affect diffraction and the resulting wave patterns. The simulation provides an interactive platform where students can actively engage with the concepts of wave interference and diffraction. By adjusting various parameters and observing the results, students can gain a deeper understanding of the principles governing wave behavior. The visual nature of the simulation makes abstract concepts more tangible. Students can observe the wave patterns, interference patterns, and diffraction patterns in real time, helping them to grasp complex ideas more easily. The simulation offers immediate feedback, allowing students to see the results of their adjustments instantly. This helps correct misunderstandings quickly and reinforces learning through trial and error. The wave interference simulation is a valuable tool for teaching and learning about the principles of wave interference and diffraction. By providing an interactive, visual, and comprehensive platform, it helps students understand how waves interact and create interference patterns. The simulation allows students to generate waves using various sources, adjust the frequency and amplitude, and observe the resulting wave patterns. Additionally, students can explore how a pair of wave sources create an interference pattern, experiment with diffraction through different apertures, and adjust various parameters to observe their effects on the wave patterns. Whether used in a classroom setting or for individual study, this simulation can significantly enhance the learning experience and build a strong foundation in physics. Through exploration and experimentation, students can gain a deeper appreciation for the complex and fascinating world of wave behavior and its applications in various scientific and engineering fields.